Okay, we're on again. What you will need is the book that I've emailed you either today or on Thursday, which is the Core 2. You can't see that, apologies. Core 2. And the page number is... where is it? Well, first question we're going to is page 154. And what I'm going to do is, this is going to be hard, right? So I'm going to do all of the examples, and then we'll see how people do that. Pop your name in the chat once you're up. So pop your name in the live chat so I know who's who and what's what. Hold on. So they check your emails now. You either got this book on Thursday or you got the book today. And the page number is 154, I think. So go to your emails now for me before we do anything else. Go to page 154 of the book that I've just either sent you or you've already got. Hello, Zareth. As soon as you've done that, can you pop in your live chat that you've got the book open? This is going to be rough today, this second exercise, right? So we need to get all our kind of like ducks in a row here. So you need paper, you need pen, you need your calculator, and you'll need that book open. All right. We're going to go through 4 examples. That shows how kind of tough these questions are going to be. There are going to be times when I'm going to teach this content. I'm only ever going to teach this on 10:30s on Monday. Right? So every Monday, 10:30, you're going to get further math material. There are going to be times where I'm going to have to go off on, well, for want of a better mathematical word, a tangent. So, for example, if one of the questions requires you to know what hyperbolic functions are, I'm going to have to go away and teach hyperbolic functions for a few lessons, right? So beware, it's going to be just like it was before in terms of like scattergun. I'm moving from here, topic to topic to topic. But then I'll come back to you and say, well, look, it worked already. It worked once already. It'll work again. All right? You just got to go with me on this. And just be ready to take notes at every opportunity because you're going to need the notes. Notes are going to be incredibly important throughout. Good quality notes like the ones Rebot makes. Ones you can follow. Yeah? Because you're going to have, sometimes I'll say something, you're going to have to go and flick back through. Right? So what you should be doing right now is getting hold of the PDF email that I've sent you. You're going to have to download it onto your computer. I don't want to hear any faffing around like next Monday, so I haven't got the file. I mean, look, I'll give you the file. Save it someplace safe. Don't use it. All right, don't make it difficult. I'll also send you the PowerPoint. I'm not going to use the PowerPoint this time. I might use it next time, to be honest with you. So, yeah, there's that. So as soon as you are done, as in you've got paper, you've got pen, you're going to need a fair bit of paper, pen, and the PDF open to page 154. We will begin. All right, and just brace yourself. Right, so as soon as you've got everything ready, pop in the chat box. That's what we're waiting for. You popping in the chat box that you are done. Good. 2 people ready. Excellent. Three. So I was waiting on the last 3 or 4 of you to be ready, and then we'll start. So I'm waiting on Zarif, I'm waiting on Kaisan, and I'm waiting on Farhan, and I'm waiting on Shein to post that they're ready to start. Okay? So as soon as you've done that, we'll move on. And we'll start doing some examples. Good, excellent, that's good. Make sure that if I'm asking you to put something in a live chat, you are doing it, right? Because I'm waiting on you. There's still 3 people we're missing. So that's Kai-san. Good, you can't find it. Let me just check that it's been sent to you. Pretty sure that I've literally just sent it to you though. I'll check on my emails. Did I send it to you? It's literally your most recent email. So if you look at your most recent email, it should say forward, so I'll forward it to you, and there should be a link to a book that you need to download. If he's struggling, can someone just send in the link and just get this over and done with? Because like other people I've sent this to have got it, so you're probably not unique on this. Where's Shiying? Does she need to be marked absent? Is Shiying here? Let's have a look. She's not up in the chat, so we'll forget about Shiying for the minute. Who else am I waiting on? Farhan. Farhan needs to kind of say something. I'm using my computer. Shouldn't be too, yeah, it won't make the slightest bit of difference. I mean, you should get it on the computer even easier. It should come out without any problems. Someone send it to him. If not, if you don't get it in the next, can you check your, literally check your top email? What does it say? I've literally sent it like 5 minutes ago. Click on that email. If there's not a file there, let me know. There's no reason why there wouldn't be. It just says, get Outlook on your phone. That's it. So that's weird. How's everyone else got this? But right, fine. Let's do it again. I'm going to forward this to you, just you. It literally should say, if you try clicking on it, I mean, it should, forget, I'll delete the kind of heading. The heading does nothing. I mean, how is it that yours never works and everyone else's does? It's such a pain in the neck. Right, there we go. All you need to do is, the email I've sent to you, scroll down, open it up, right? It's a forward, so you need to read what the message that's been forwarded, not the bit that says, this was sent from my iPhone, because it was, right? And there's a link. You click on the link and open the file. To be honest with you, I'm going to just start the examples now, but if that still hasn't worked out for you, can someone else just send him a damn email, right? All right, number 1. The first 2 questions are things you should be able to do. I say should be able to do it probably the first one you can, all right? So the first differential equation we're going to solve today is one that should be reasonably familiar to you. And it says dy dx is minus y over x. But then it asks you to do something else. So this is example 1 on page 154. Sketch members of the family of solution curves represented by the general solution. So basically what it's saying to you there is, okay, you solve the differential equation. What does it look like for all the different things that the constant can do? And this will, I promise you, make more sense to you when we do it, okay? So can I ask you to solve the differential equation for me? Because this is something you should be able to do. It's a nice, easy. Now, someone email it to him, seriously. It's getting on my nerves now. I haven't got time for this. Okay, wait. For some reason, it's causing trouble on this. I actually see that you've asked for a thing. I'm going to give you access. So just hold on a second. It says, yes, approved. I've approved your access. Well, I will in a second. It's taking a minute. Right, it's been approved. So now you have got access. There you go. Why is that you alone have that problem? I do not know. So what everyone else is doing is solving that differential equation. All right. So remember that separation of variables. If there's anyone in this room that can't do this, first of all, have a full-on panic attack, because like the lessons of how this is like, that's the bare minimum to even understand what's going on. And then you can ask for help, right? But have the panic attack first, because your life is going to be difficult if you don't know how to do this question. It's about as easy as the differential equation as you could ever have. But if you are struggling, ask for help. There's no point just kind of struggling in silence. It was not going to help you. So as soon as you've got an answer, pop it in a live chat for me. If you're struggling, pop that in a live chat for me. I need information out of you guys, basically. So you got y equals plus or minus et. Okay, that's fine, Sheem. You're solving that differential equation, just so you know. All right. You've already started with the book, so you know when I say page 154 in the core 2 book what I'm talking about. I'm just going to check what Iman's answer is. So, do they agree? I'm not sure that's what. Yes. Almost is the answer to that. It's almost. The only difference that Iman they make is they go e to the c is a, and I've shown you that before. Okay, so I'm going to give everyone else a few seconds to catch up with Iman. Well played, Iman. You got it right. Let's not be kind of stingy about this. You got it right. I'm just saying, be aware that e to the c is generally given as a. I'm going to give everyone else a minute or two to catch up with them, right? If you can't do this, you need to own up now, right? Because there's going to be no place to hide in this lesson. You'll just get destroyed. So if you cannot do this, ask for help now. It's embarrassing because you spent 3 lessons on it. Clearly, you're not been doing any work outside of class. But better to be embarrassed than, fail your exams, surely, right? So I'm just going to wait on everyone else to confirm either they understand it or they need help. That's what we're waiting for. So I'm waiting on you guys just to either confirm that you've got the answer or put a message saying that you can't do it. That's what we're waiting on. We're not going to go any further until that happens. Excuse me. So again, still waiting on people to come back with either they've got the answer or they haven't got the answer and they need help. So I was waiting on you. It doesn't take this long to solve this equation. It should be much quicker. I'm waiting on you guys on this. And the only person who's popped up an answer so far is Iman. Could you write a solution so I could? Yeah, for sure. Y equals, you can't see that, I do apologize. Y equals, what am I going to go with that? A over e to the x. All right, that's what I'm going with anyways. Bear with me just a moment, I'll check that I've got that right. Yeah, plus or minus. The reason why the plus or minus from the modulus, all right, in case you're curious. So that's my solution, where a equals e to the power of c. All right. If you need help with it, you need to pop something in the chat. Say, I need help with this. I need you to do this as an example. All right. But this is like very, very basic. This is almost like, in terms of the first part, simple as some of the stuff we're doing 3 lessons ago. Yeah, agree with you, man. Agree with you. So I'm just waiting on people. I'm guessing there's some kind of lag, or just people have no clue what the hell they're doing and they're not willing to say it. But at the end of the day, you're gonna have to say it. Isn't it over? Yes, isn't it over X? My apologies. Thank you. That was a miscopy. My apologies. It's a good spot, Kaisen. Well done. Good job. So that's 3 people that have come up with, Iman, Reba, and Kaisen have come up with solid answers here. The question before the house is what happened to the other 4? All right. So where's Farhan? Where's Sheeing? Where's Zarif? And where's Kelvin? You guys need to pop up in a chat and express your opinion. Do you understand this or do you not? Okay, and that's kind of what I'm waiting on here. You've been asked like a few times now, so let's either get an idea. We can do this or we can't. Yeah, we can't. We need to teach it again. If we do it, then we can move on. I don't think I'm confident. Well, you're going to get another chance to practice it. Did you get the answer yourself, though? Again, we're still waiting on a few people. And to be honest with you, I'm tired of waiting on these people. What I'm going to do is just going to start marking people absent if they don't answer. Simple as that. Unless you've got a very good reason like your internet's dead. I'll start marking people absent who don't answer fast enough. Right, anyways, let's move on. Zarif, if you come up with a particular thing that you're not confident with, please say so. Then I'll support you. I'm just going to sketch out the answer on this just for those people that are, totally incompetent. Dy dx equals minus y over x. Obviously, you separate the variables. So that's going to go minus, I don't know where they start the minus. I'm going to put the y there because I'm lazy. 1 over y dy equals minus 1 over x dx. Yeah? I'm not sure that's the way the textbook did it. I'll check for you. With this, they start the minus sign in the same place. Integrate both sides, you get ln y. You get minus ln x plus c. Yeah? Put them on the other side, you get ln xy. If you need any help explaining why that's true, equals c. And then you do need to ask for help if you're struggling, you don't understand what the hell happened there. Modulus, 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 modulus. Just moving on to this side. Let's pop it here. If ln xy equals c, we can e both sides and you get modulus xy equals e to the c. Stuck the modulus on there. I mean, Sheeing, fair enough, just watch it. The thing is, it won't come back to, like, the YouTube videos take a little while to upload. So just, like, maybe tomorrow, realistically. If it doesn't work, it doesn't work. There's not much you can do about it, is there, really? So you've got modulus xy equals e to the c. So y equals e to the c over x. The modulus forces the plus or minus, and e to the c is just a. So y equals a over x with a plus or minus 1. Okay, part 1 done. Okay, good. So that's how that one does. I've got another 3 examples to go through. So we're going to have to pick up the pace here a little bit, right? And I also need to move this around a bit so you see a bit more of, it's a bit more like that. That's good. Okay, round 2, example number 2. Remember, you've got an exercise to follow this. So, like, it's in your, okay, by the way, I didn't finish the first one. Solution curves. What the hell is that all about? It's a set of solution curves. And that's what's the new content, well, for the first half of the lesson anyways. What is a set of solution curves? Set of solution curves, very, very simply, is imagine A could be any number, positive or negative. What would the graphs look like? So we had y equals a over x. I'm going to ignore the plus or minus just because it doesn't actually matter for this particularly. It obviously does matter, but, it's not the end of the world. In that we're going to make a positive or negative anyway. That's why it's not the end of the world, to be clear. What does a to the x normally look like? If a to the x is positive, then you got a graph that looks like that, yeah? And I mean, as A changes, you get varying different graphs, right? And there's a lovely diagram of this on page, page 154. So you get all different types of similar sort of graphs that look a bit like that, depending on how big and how small A is, yeah? And I mean, if you want a better diagram of that, by all means, look at the one that's on page 154. But imagine A turns out to be negative. So ignore the plus and minuses from there. Just go, well, okay, well, look. Imagine it was negative. Then your graph would look like that. It's minus A over X. That's what it looks like. So that's the set of solution curves. So you basically say A can be any number in the reals, not complex, in the reals. What would the graph look like? Well, if it looks positive, it's going to look like that. If it looks negative, it's going to look like that. So that's your set of all of your potential solution curves, because remember, you don't know what A is, yeah? And now you might say, well, VJ will look. A e to the x surely would only ever, or e to the c would only ever be positive, because e to the c is anything. But remember, you do have the plus or minus on it. And that's what gives you the justification for having a negative A. Because even though A itself can only ever be positive, e to the power of anything can only ever be positive, it does have a plus or minus like thing on it from the modulus earlier on in the question, right? So that's what solution curves are. They're literally a set of the drawings, the sketches of all the things that could happen, right? So if A turns out to be positive, you'd get these graphs. So depending on how big the A is, or how small the A is, the curves would look like various degrees of this. Similarly, on this side, if A was negative, the graphs would look a bit like that. Let's see what people have got to say on that. So if you want to have a better understanding of that, page 154 is really good for that. Remember, there is also a PowerPoint on it as well. But that's how solution curves work at a very, very basic level. We're going to spend a lot of time on them, so don't panic. If you do not understand, you've got now a minute to say so. All right? If you're going to say, I do not understand this, do not attempt to move on. Um, 154 for you is identity, is it? For me, I can see if you just type in 154 into the little box on the PDF opening file thingy, you shouldn't have a problem. In terms of the actual textbook number page itself, it's 148, okay? But I'm using the thing that when you open up the file, if you type in 154 into the box, so if 154 is not working, if you try 148, that should do it for you. Right, number 2. Slightly harder one this time. So this one I want you to try. I say slightly harder, considerably harder. X cubed dy dx plus 3x squared y equals sine x. So you can see the challenge is ramped up quite considerably. Now, this one is a little bit harder. And it requires a little trick. So I'll give you about 2 or 3 minutes to. Do you use the product rule? Very good. Yes. Am I using the core 2 book? Yes. The one I emailed you on Thursday. Quite right, Iman. Both on both counts. Yes, you're using the core 2 book. Yes, you're using the product rule. So if you're struggling with trying to integrate this guy, if you're trying to separate the variables, that's not a good shout here. That's not how you do this. You won't be able to separate the variables easily. Because what you'll end up having is an integral that's going to be absolutely monstrously difficult. First of all, what you need to do is factorize the x's out of that. Yeah, so basically this is not going to be one that, separates. The separating the variables is not the right shout. Iman's giving you a huge clue there. They're going, should I use the product rule? I mean, it's a thought, isn't it? You're struggling to do this one. Okay, I'm going to walk you through this one because this one is legitimately difficult, right? This requires you remembering how implicit differentiation and integration works. Implicit differentiation, yeah? Oh, you can't see any of that, I apologize. So if you remember, if you had something like, I'm going to do this one on purpose, I know what this is. Let's go with x cubed y, okay? And you have to differentiate that implicitly, okay? You'd have to do the product rule on it. So this is u, and that's v, and then do the product rule on it, and let's see what happens, right? So you do implicit differentiation on this, you'd get 3x squared y. Okay, let me do that properly. I'm going to do that step by step. That's u and v, so u dashed is 3x, and v dashed is dy dx. Remember, the differential of y is just dy dx, right? 1 dy dx, however, right? So if you do the product rule on that, so u dashed v would be 3xy. Sorry, 3x squared, my apologies. Still can't see that, can you? So if you differentiate this guy, you're going to get 3x squared y dy dx. No, 3x squared y. And then the other guy is going to be x cubed dy dx. And that's amazingly enough just this guy. Yeah? That's just this guy. So we can say straight away that if you differentiate x cubed y, you get sine x. Can I move the camera here? There you go. Okay? So that makes a little bit more sense. Yeah. Done. So what's the thought process that's going on there? I'm saying if I implicitly differentiate x cubed y, I get the left-hand side of this. All right? So what does this require you to know and understand? It requires you to know how to implicitly differentiate. Yeah? But it also kind of forces you to know, okay, well, I need to spot that. You need to spot that if you differentiate this, you'd get that. All right? So that's why this is quite, as I said, it's quite a difficult question. All right? Okay, now we know that if we differentiate this, we get that. We can write this equation. So you've got d dx, so the differential of x cubed y equals the integral of sine x. All right? So the trick that you used there, the thinking that you did, was that, okay, I've got something that obviously looks like something that's been product ruled in the past. So if I find out what was product ruled to make what I've got in the question, I can say, well, the differential of this is going to be the integral of the other guy. So I mean, we know the integral of sine x. So we can go d dx x cubed equals the integral of sine. Let me just accept. Zarif is trying to get hold of the textbook, so just give me a second and I'll sort that for you. I hate the fact it's giving such a pain for this. Such a nuisance system, this is. Thank you. Yeah, so Eman sent the book to everyone, so just use that. I've also given access to a load of people, so that's fine. Yeah, don't worry. Eman has sent it around again. Thank you very much, Eman. That's very useful. I much appreciate it. So where are we at with this question? We can say logically then. So that should be sine x. My apologies. I was just thinking ahead there. So we can say logically x cubed y. The integral of sine x is minus cos x. So minus cos x plus c. And then it's relatively simple just to go y equals minus cos x over x cubed. And because of the fact we've already forced a c here, that c has to be over x cubed as well. I mean, maybe you could turn that into a d. I don't really care. Do we understand the logic behind it? I mean, it's hard. That's what I mean. I did question to you for a reason, because it's hard. But this is kind of a trouble. I mean, this is a standard we're now going to be working at. So you need to pop in a chat. Do you understand how that happened? If you don't understand, you need to explain what you didn't understand. And then if you can do that as fast as you possibly can, please. Because there's still another 2 examples worth of stuff before you can even look at the textbook exercise. And that's exercise A, for God's sake. So the quicker we push, the better off we'll be. So not email me, pop on the live chat straight away whether you understand or not. And if you don't understand, just don't put I don't understand. That's useless, doesn't help. So I don't understand, okay, how you got the x cubed y, for example. Or I don't understand how you got this line or that line or the other line, yeah? So you need to explain why. That you don't understand. And I'm waiting on you for that. Okay, good. Got it, good. Okay, cool. We've got 2 people that said they've got it. I'm reckoning I need to hear like a few more people on that. Because again, that was a very hard question. I mean, you'd have to spot that product rule was involved. You have to remember implicit differentiation. So it goes back to you knowing your maths. All right, so I'm just going to wait on a few more people. Did you just guess x cubed y? No. If you look at the original question, I'm going to rub this out. Look at the original question. The original question said x cubed y dy dx plus 3x squared y on the left-hand side. And that looks like your product rule thing, yeah? You've got an x cubed and a 3x squared, so clearly this would be u and that would be u dashed. And you've got a y and a dy dx, that's a v and a v dashed, yeah? Does that make sense? So if I was going to write this out, so just this is what the question said. If I was going to write this out, say this, let's call this u, let's call that u dashed. And actually, you're more familiar with u dash v, v dash d, aren't you? So let's do it that way. So this will be v, and that will be v dashed. That would be u, and that will be u dashed. Okay, so again, you can straight away see that that's going to be, it looks like a product rule thing. Because if you differentiate y, you get dy dx. If you differentiate x, you get 3x, right? Well, if you are doing product rule, what do you start with? You start with the UV, don't you? And that gives you the x cubed y. That's the reason why I thought x cubed y. That's the logic behind it. So the skill is going, okay, I understand that this looks like product rule. If it were product rule, what did I start with? Yeah, what is UV? All right. Okay, so we're now going to have a look at the third example, unless anyone's going to object. Let's see if anyone has object. What is this called? Differential equations. I mean, you've got a chapter heading. It's differential equations. It's just more differential equations. Right. 2 more examples. God have mercy. We'll get there. Example 3. Okay, example 3 requires you to know a new formula. I'm going to show it to you. If you have a differential equation in the form dy dx e plus p x y, this is exactly how the textbook's done. I'm literally copying the textbook, so you can go straight back to the textbook and check this and use it. If you've got something in that form, you can solve that equation by multiplying every term by e to the integral p of x. All right, and I'm going to show you a couple of examples of this. All right, so you can solve this is called a first order differential equation. This is first order because you've only got dy dx in it. Yeah, so dy dx is your highest term. That's first order. If you had d2y over dx squared, then you'd have a second order. And we'll get there. I mean, pray, but we'll get there. So you need to multiply through by this. Okay, e to the power px, and that's going to help you solve that equation. This is, guys, called an integrating factor. Okay. So this guy here, e to the power of p of x, so e to the power of the integral of p of x is an integrating factor. And if you do that, if you multiply through by that, it's going to make your life a lot easier to solve equations. And I'm going to show you a couple of examples of that, okay? But for now, can you write down that rule? Okay, write down that rule. So in about 30 seconds, I'm going to take you through a couple of examples of this, and that's going to be us done for today. Your exercise, obviously, is to do 7a. You will struggle. Let's be fair, you will struggle. That's all right. Well, you need to do as much as you can, and then we'll pick it up again, probably on Thursday, as well as doing some revision in general on Thursday as well. Okay? Okay, so the example we're going to run here is dy dx. It's called dy dx minus 4y equals e to the x. So here, if we're going to look at this, the p of x is just going to be minus 4. All right? And the q of x is just going to be e to the x. Okay? So what we're supposed to do is times through by the integral of e to the minus 4. All right? Which I'm sure you get quite easily is just going to be e to the minus 4x. So this is what p of x is. Sorry, that's your integrating factor. All right? So this is e to the p of x. And that's your integrating factor right there. Everyone happy so far? I'm going to stop there for a second. So what I've done there in the first part of this question is I've got my differential equation. I'm going to solve it using the integrating factor method. How am I going to do that? E to the px, e to the integral of px, and get what that is. All right? Okay? E to the integral of px is e to the minus 4x. Now, the next thing I'm going to do, let's see if everyone's happy with that. Do as much as you can today and then submit the rest tomorrow. I mean, we'll be reasonable about it. So we've now got e to the minus 4x dy dx. Oh, well, that's curled up there. E to the minus 4y dy dx minus 4e to the minus 4x equals e to the x times e to the minus 4x. Okay, so what I've done there is I've multiplied through by the integrating factor. And now if you're clever, we're going to use exactly the same trick. So I'm going to move that camera so you can see that better. We're going to do exactly the same trick that we used before because this looks like product rule now as well. Yeah? So if we say that this guy here, let's call this guy V. This whole thing would be, so that should be a Y there. This thing here is V dashed. This is U, and this is U dashed. You can see we've got U dashed V plus V dashed U. Why is it a plus? Because this whole thing is V dashed, all right? So guess what? We've got product rule again. So what can we do? We can say straight away that I'm going to leave that there for you to copy just for a second. And I hope you saw that. That's what the integrating factor does. It makes you into product rule, yeah? So you can just go, well, UV is just going to be e to the minus 4xy. And then we can start writing stuff. We can start writing stuff like, what have I got here? E to the 4xy, e to the minus 4xy rather, is equal to the integral. And if you just collect like terms on the exponentials from before, I don't know how you can see this. Let's see a bit better now, hopefully. Then you've got e to the x times e to the minus 4x. That gives you e to the minus 3x. All right? And that's not too difficult of an equation to solve. I'm just going to solve it for you. I hope that makes sense so far, right? So what is the point of the integrating factor? It turns things into normal differential equations into one that can be solved by the product rule trick. All right? I'm going to rub this out now. Hopefully you've copied it. I'll give it a few more seconds, then give you a chance to copy it. Right, cool. So we're now up to the situation where we can say e to the minus 4xy is equal to the integral of e to the 3x. We can tie that up quite nicely by saying, well, the integral of that is just going to be 1/3 e to the 3x. Yeah? But hopefully that makes sense to people. That's how that works. Plus c. And you've got e to the minus 4xy. Divide through by the e to the minus 4x. And then you've got 1/3. Well, dividing by e to the minus 4, that's surely going to be e to 7x, isn't it? You add them up. And then you're going to get c over e to the minus 4x. All right? And there you go, equation solved. I'll check if that's what they've got. Well, dividing through, there's one thing I could have easily done. Dividing through by a minus, it just means that's going to be c e to the 4x. But other than that, I think they agree. Yeah? And that part of that thing, yeah, that's a minus sign there. That's the only mistakes I see there. And then if that's a minus, that'll just be a plus there. So e to the x. There we go. All mistakes sorted. All right? So just silly mistakes more than anything else. The trick is to use the product rule. Yeah? And also, there isn't much more than that, really, on that question. So there's your final answer. Anyone got any particular issues on that? I'm going to stop for a couple of minutes. If anyone needs to ask any questions, ask for any help. And then I'm going to do one last example and we're done. Right. Example 4 then, unless people have got a question. Let's see if anyone does. No, it doesn't look like it. Example 4. This is a two-part question. One, you have to do the separation of, the integrating factor thing. And then the second thing you've got to do is work out what any constant is. They're not particularly difficult. I mean, the math is quite tricky, but you know. Right, anyways, let's just do it and get on with it. Let me stop this. Cos x dy dx plus 2y sine x equals cos to the cos fourth here. So I hope that makes sense to everyone. Yeah, I hope that seems reasonable. So this is what we've got. I mean, we've got here now an interesting question where this is a bit awkward, but I can do something by dividing through by cos. So if I divide through by cos, I've got dy dx equals 2y tan x, which is considerably easier to handle, equals cos cubed x. And now we're in a position to use an integrating factor. And the integrating factor would be the integral of, so p of x here is 2 tan x. So our integrating factor will be the integral of 2 tan x, all right? Now, a little bit of thought. We should know that if you integrate tan, and this will be in your formula booklet, if you integrate tan, you would get ln sec x. I mean, I'll kind of show you that as well. So you've got e to ln sec x, yeah? And if you're clever about powers, I'm going to put that up here. So I'm going to pop. So we've got this. I mean, I'm going to leave, in fact, I'm going to ask you to copy up this and I'll give you a minute. And then I'm going to finish this. So right now, we've got our integrating factor is this guy, all right? And if any of the steps you don't understand, just ask, all right? Okay, so we've got up to the integrating factor bit. I'm going to tidy up the integrating factor some by going, well, if I've got e to the 2 ln sec x, that's just e to the ln sec squared x. Yeah, I hope that makes sense to people. And that's just sec squared x. Because e and ln cancel. So our new integrating factor is sec squared x. We tidied it up. Put it back to the question now. So the question goes, sec squared x dy dx. So basically I'm multiplying the formula through by sec squared x. Gives me plus 2y sec squared x tan x. And that all equals sec squared x cos cubed y. So again, you're looking on the left-hand side for what am I talking about? Product rule. And it's pretty clear that if you made this guy u and that guy, what should we call this guy? I think this guy, the sec squared is the u, and then I think just the y is the v. Then you've got product rule. And if you don't believe me, by all means, differentiate and see how that works for you. So this is u, that's v, the y is anyways. 2 sec squared x tan x. So this is obviously going to be v dashed, and this is going to be this and this put together. 2 and the sec squared tan x is your u dashed. All right. So uv here would be y sec squared, or sec squared xy. Yeah, let's call it like that. So we can say y sec squared x is the integral of, and now look at this guy here, cos cubed times by sec squared. Well, sec squared is just cos squared, 1 over. So that's literally just going to be the integral of cos. So that should be an x there, shouldn't it? So that should literally be just the integral of cos x. So you've literally got y equals, I don't think you can see any of this now. Can you see any of this? Y equals, the integral of cos is sine. So it's going to be sine x divided through by sec squared. Dividing by sec squared would give you, basically times in by cos. So divide through by sec squared. That's like times in by cos. So you get sine x plus c over sec squared x. All right. And then even this can be tidied up. I'm going to just show you that for a second, and then we'll tidy it up properly. Because sine divided by sec squared, that's the same as like 1 over cos squared. So that would just be sine x cos squared x plus c cos squared x. And then you could just substitute the coordinates in. All right. And that's part B. If you wanted to find out what actual c was, you'd substitute the values that they give you for this and in there, and you can find out what c is. Okay. Now that's pretty full on. I get that. That is pretty full on. You substitute 2 and 0, and you can, the answer's right, by the way. You are going to struggle here. You need to try this. You need to struggle. You need to fail this time. All right? Because then on Thursday, what you're going to come back with is a whole bunch of questions saying, I can't do question 1, 2, 3, 4, 5, whatever, whichever ones you can't do. And that's where I can explain it some more. All right? I want you to spend the next half an hour plus some homework time. You need to work on this before Thursday, doing every question you possibly can. You should be able to do 1 and 2 at least, right? You need to write down what questions you can't do, and then you need to bring that to Thursday, all right? This stuff is stuff you're going to be examined on. This is not something that's optional. It's not something that you can, I messed it up, it's fine. I'm in quarantine, it doesn't matter. No, you need to fix it, okay? You need to talk to me. You've got a PowerPoint, you've got a book. You can email me. I wouldn't bother email me. You could if you want to. I don't mind. You can email me if you want. I don't mind. Because I'm going to cover this again, I think, on Thursday anyways. All right? But you can definitely email me the questions you want to see done. That would be great, because then I can prepare them for you. All right? This is hard. It's going to be difficult. You need to work on it now. All right? So I'm going to leave you with that. If you've got any further questions or any issues, make a note of them, email them to me, and I'll either cover them via email or I'll cover them during the lesson on Thursday. Okay, I'm going to keep the YouTube channel on in case anyone wants to chat about any particular issue from the question for another 4 minutes, right? Oops. There we go. Camera's having fun. Let me sort that out, because that's being a bit silly. Keep that there. Keep that there. Keep that there. There we are. All right, that's not too bad. I'm going to pull this along. So I do apologize. Camera having fun. Yeah, that's fine, Weber. Have a go at it. If you don't, obviously, we're going to struggle. It'll be on you to kind of make sure you get yourself sorted on that. That's not ideal. I mean, 7A, yep. 7A is what you should be trying. Okay? I'm going to hang around here for about another minute or two. So if anyone else is struggling, let me know. Should we still send you the work today? Do as much as you can and send me the work. I want to see an effort. You cannot say I can't do this without showing me what you did do. All right? So if you got 6 lines of working out, you can't get any further, and that's the same for every single question you try, fine. I want to see that. What I won't accept is nothing. You can't go, I'm baffled. Because right now, if you're baffled, you can ask me now. If you're baffled, why aren't you complaining? Do you know what I mean? So you've got about another couple of minutes to complain if you're struggling completely. But you should be able to at least start some of this, right? Go back and watch the video tomorrow if you know, to give yourself a bit of a helping hand. This video will be on probably by tomorrow morning. It should be. It doesn't take that long to upload. All right, I think I'll give it another minute or so for anyone else who wants to ask any questions. I hate one does, so I'll hang around here for the minute anyways. Right, let's roll.